In this video, we will be determining how to identify the trigonometric functions of real numbers. This includes identifying the value of the 6 trigonometric functions for a given angle t. This also includes determining the 6 trigonometric functions given the terminal point associated with a particular angle t. The first problem wants us to identify the 6 trigonometric functions for the value of t being equal to 7 pi over 4. In order to determine the value of sine of 7 pi over 4, we need to remember back to the determination of the values of the terminal points on the unit circle. If we can remember, the sine of any angle is equal to the y-coordinate of its terminal point on the unit circle. So, if we know that the sine of 7 pi over 4 is equal to the y-coordinate of its terminal point, we can determine that the sine of 7 pi over 4 will be equal to the negative square root of 2 over 2. In order to determine the cosine of 7 pi over 4, we need to remember that this is equivalent to the x-coordinate of our terminal point, and we can therefore also say that this value will be equal to the square root of 2 over 2. Determination of the tangent of 7 pi over 4 requires the knowledge that the tangent of any angle is equivalent to the sine of the same angle, in this case 7 pi over 4, divided by the cosine of that same angle, 7 pi over 4. Therefore, this will be equivalent to the negative square root of 2 over 2 over the square root of 2 over 2. So we can say that this is equivalent to negative 1. The cosecant of any angle is equivalent to 1 over the sine of that same angle, in this case 7 pi over 4. We can therefore say that the cosecant of 7 pi over 4 is equivalent to negative 2 over the square root of 2. Now, we want to avoid having a square root in our denominator, so in order to get rid of that, we are going to multiply by square root of 2 over square root of 2, and this will give us our final value of negative 2 square root of 2 over 2. Our secant of 7 pi over 4 is equivalent to 1 over the cosine of 7 pi over 4. We can therefore say that this will be equal to 2 over the square root of 2. And once again, we want to remove the square root in our denominator, so we multiply by the square root of 2 divided by the square root of 2. And we find that the secant of 7 pi over 4 is going to be equal to 2 square root of 2 over 2. The 2's can cancel, and we get square root of 2. Additionally, in the cosecant of 7 pi over 4, the 2's can cancel as well, and we get negative square root of 2. Finally, the cotangent of 7 pi over 4 is equal to 1 over the tangent of 7 pi over 4, and it will therefore be equal to 1 over negative 1, or simply negative 1. For our next problem, we've been asked to determine the same 6 trigonometric functions, this time for the value of t being equal to negative 5 pi over 3. Beginning with sine, we know once again that this is equivalent to the y-coordinate of the terminal point for this angle, and if we can remember back to our unit circle, we know that this is equal to square root of 3 over 2. In order to determine the cosine of negative 5 pi over 3, we know that this is equal to the x-coordinate of our terminal point, and for our unit circle, this will tell us that we have 1 over 2. If you're having a hard time with these, remember that the sine of negative 5 pi over 3 is also equivalent to the sine of pi over 3. The same is also true for the cosine of negative 5 pi over 3 being equal to the cosine of pi over 3. In order to determine the tangent of the negative 5 pi over 3 angle that we are working with, we can once again say that sine of negative 5 pi over 3 over cosine of negative 5 pi over 3 is equivalent to the tangent of negative 5 pi over 3. This will therefore be equal to square root of 3 over 2 divided by 1/2, and this will give us square root of 3. In order to determine the cosecant, we simply take 1 over the sine of negative 5 pi over 3. This will be equal to 1 over square root of 3 divided by 2, which is equal to 2 over the square root of 3. So we multiply by square root of 3 divided by square root of 3, and our final value is 2 square root of 3 divided by 3. The secant is 1 over the cosine of the same angle, cosine negative 5 pi over 3, which will be equal to 1 over 1/2, or simply 2. The cotangent of negative 5 pi over 3 is once again 1 over the tangent of negative 5 pi over 3. And so this will be equivalent to 1 over the square root of 3. Then we multiply by square root of 3 over square root of 3 to remove the square root in the denominator, and we get square root of 3 over 3 for our value of cotangent of negative 5 pi over 3. For our next problem, we wish to determine once again the 6 trigonometric functions. This time we are given the terminal point rather than given the angle t. We begin with the problem where our terminal point is x-coordinate 11 over 12, y-coordinate square root of 23 over 12. We know from our unit circle video that the sine of any angle is equivalent to the y-coordinate of its terminal point, and we can therefore say that this is square root of 23 over 12. We also know from our unit circle video that the cosine of any angle t is equal to the x-coordinate of its terminal point, which will be 11 over 12. The tangent of any angle t is always equal to the sine over the cosine, or in this case the y over the x-coordinate, which will therefore be equal to square root of 23 divided by 12 over 11 divided by 12, and we therefore have the tangent of our angle t given the terminal point as square root of 23 over 11. The cosecant of the angle will always be equal to 1 over the sine, or in this case 1 over the y-coordinate, which will be equal to 12 over the square root of 23. Removal of the square root in the denominator of this fraction will give us 12 square root of 23 divided by 23. The secant of the angle t given the terminal point will be equal to 1 over the x-coordinate, which in this case will be 12 over 11. Finally, the cotangent of our angle t given the terminal point will be equal to the opposite of the tangent, or the inverse, which in this case will be x over y, or 11 over 12 divided by square root of 23 over 12, which will therefore give us 11 over square root of 23. Removal of the square root symbol in the denominator by multiplying by the square root of 23 over the square root of 23 will give us a final value of 11 square root 23 divided by 23. For our last problem, we wish to do the same thing once again. This time our terminal point will be x equal to 6 over the square root of 85, and y equal to negative 7 over square root of 85. For sine of t, we once again set it equal to the y-coordinate of our terminal point, or negative 7 divided by the square root of 85. Removal of the square root symbol in the denominator by multiplication of the square root of 85 divided by the square root of 85 will give us negative 7 times the square root of 85 divided by 85. The cosine of t will be equal to our x-coordinate, or 6 over square root of 85, Once again, removal of the square root symbol in our denominator will give us the final value of 6 times the square root of 85 over 85. The tangent will always be equal to the y-coordinate of our terminal point divided by the x-coordinate, which in this case will be negative 7 divided by the square root of 85 over 6 divided by the square root of 85, which will therefore give us the tangent of our angle t as negative 7 over 6. The cosecant of our angle t given the terminal point will always be equal to 1 over the y-coordinate, which in this case will be the square root of 85 divided by negative 7, or negative square root of 85 divided by 7. The secant will always be 1 over the x-coordinate, or in this case, square root of 85 divided by 6. Finally, the cotangent of our angle t will simply be equal to the x-coordinate divided by the y-coordinate, or the inverse of the tangent of the same angle, and we can therefore say this will be equal to negative 6 divided by 7. This concludes our video on the determination of the trigonometric functions of real numbers when given an angle t or when given a terminal point.